Hello. In this lecture we will discuss the AES cipher block chaining method. With cipher block chaining, the sender needs to create a random initialization vector. This has to be the size of the encryption protocol blocks. In our ES, this is 128 bits. So, the sender creates a random initialization vector of 128 bits. It will split the plain text into 128 bits chunks. The last chunk can be less than 128 bits, however, it has to be in a 16 bits block increments. Padding can be added to fulfill this requirement. Now, the first round is the initiator generating the initialization vector. It will take the first chunk of plain text and XOR it with the initialization vector. It will then encrypt the outcome using ASCII IDE. This will yield ciphertext for chunk 1. It will take the output and XOR it with the plain text of the second chunk of 128 bits. The outcome will be ciphertext block 2. It will take that ciphertext block and XOR with plain text 3. Now, that XOR outcome will be encrypted using AES as well. The encryption operation occurs with the ASCII IDE. So ciphertext block 1 gets XORed with plain text 2, encrypted. The outcome is ciphertext 2. Ciphertext 2 gets XORed with the plain text chunk 3, and then encrypted as well with ASCII IDE. The process continues until all the plain text blocks are encrypted. Now it makes sense why this encryption method is called cipher block chaining. Once all the plain text chunks are encrypted, the ciphertext is concatenated together. It will craft the packet. First it will add the ASP, SPI, then it will add the sequence number of this ASP packet. It will also add the initialization vector. This number cannot repeat for this security association. So, you notice that this is sent in clear text in the payload, right after the sequence number. This is not a secret number, it is used for randomization. Finally, it will append the encrypted ciphertext to the packet. The integrity check value is the outcome of the authentication protocol. CBC is usually coupled with SHA-1 or other authentication protocols for integrity. The CBC method doesn't do integrity authentication, this is left to other protocol. CBC is not a combined encryption method. The outcome of the authentication protocol operation is the integrity check value. Finally, it will add the integrity check value to the packet and send it on to the recipient. The IPsec peer gets the packet. It will first pass the SPI and reference the Security Association database. In the Security Association database, it will get the ASCII ID for encryption of this peer Security Association. It will split the ciphertext into 128 bits chunks. It will decrypt the first chunk and XOR the outcome with the initialization vector to get plain text chunk 1. It will use ciphertext chunk 1 and XOR it with the outcome of decrypting chunk for ciphertext block 2. This gets plain text 2. For chunk 3 it XORs the decrypted chunk with ciphertext 2, and so on. This will unravel all the plain text that was encrypted by the sender. The plain text chunks will be concatenated together and sent to its intended destination. Now, a couple of things to be aware of. AES can be done using 128 bits, 192 bits, or 256 bits. The initialization vector for all three flavors of AES is still using a block chunk of 128 bits. So, the IV for all those flavors of AES is still a 128 bits initialization vector. Hopefully you enjoyed this lecture. We will talk more in the next lecture.